Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Previously, we looked at arrays, which allowed us to keep a sequence or a group of related data together inside of the same variable. So we would create an array by providing a data type, and so each item in the array had to be of that data type. We would also provide the number of elements we expected in the array by defining that number between a set of square brackets. Now that we have that predefined sized array, we could add items into each element of the array or retrieve values out of each of the elements of the array by indexing into the array using a zero-based index to index in and address one specific element of the array. Now, once we had the data collected into an array, we could do some interesting things. We could iterate through the array and investigate each element of the array. Or we could even pass the array around as if it were one variable, pass it in, for example, as an input parameter to a method. But you recall at that time I also said that at some point we would talk about collections. And I even gave collections a nickname, calling them arrays on steroids, all right? And I think you're going to agree after this lesson that collections are great whenever you're working with all data types, especially those data types, those custom data types that we've been working with up to this point in this series of lessons. For example, the car class that we created ourselves. Now, as far as the .NET Framework class library is concerned, it will often use both arrays and collections depending on the need. But I think you will probably wind up preferring to use collections in your applications because of the rich filtering, sorting, and aggregation features that are available to collections through a technology, a language called LINQ, L-I-N-Q, which stands for the Language Integrated Query. It was a very innovative feature whenever it was first introduced back a number of years ago in C# and other .NET languages. Other languages have since implemented something similar to it, but we're going to dive into that topic of LINQ and what you can do with it in the very next lesson. But first of all, let's talk about collections. We're going to talk about two collections specifically, lists and dictionaries. Now, truth be told, there's probably a dozen additional varieties of collections that you could use for very specific purposes. They each have a superpower. They each have a very specific use case where they're intended to be used. I find myself using lists and dictionaries 95% of the time, so we're going to focus on those for this lesson. But after this lesson, by all means, feel free to go off and learn all of the additional collections that are available to you and what they can do that's a little bit different than the list and the dictionary. Okay, so suppose that I have a number of cars on my car lot and I want to write an application that allows me to manage them. So I need some way to collect all of the individual instances of the car class together into a single array or collection. Now again, I might use an array of cars, but I think I'm probably going to choose to use a collection because of the added features that I'm going to gain using collections. We're going to talk about a bunch of different types of collections, but I want to start off with kind of a conversation about an older style of collection that's no longer used anymore to show why there's a newer style collection that's available, and it'll help you maybe understand that idea a little bit better. As you can see, I've got a project called Working with Collections already set up here. Please take a moment and create a new console window project. I'm also going to paste in two classes that I've defined, simplified version of the car class that we've used before, and then also I'm going to create a book class, as you can see there at the bottom. Very simple classes. And the next thing that I'm going to do is actually paste in some code to actually create new instances of each of these classes and then populate their values. So you may want to pause the video yet a third time and copy in the code that I have copied to screen there as well. All right, so the very first thing that I'm going to want to do is to work with a collection, and I'm going to work with something called an array list. And so let me just say this about array lists, that they are dynamically sized, which is one of the great benefits. You don't have to do anything to say I need to add one more item and another item and another item. Remember, with arrays, I said it was possible to resize an array, but it's a little bit of an advanced operation, not so with an array list. So that's one of the big benefits. So you can just keep adding items to it and it'll be just fine. It'll also support cool features like sorting. You can easily remove items from the collection and so on. So let's go ahead and create a new instance of this array list. And when I do, notice that we don't already have a reference or a using statement to a namespace. So what I'll have to do is hit Control period on my keyboard, and you can see that it is in a namespace called using system.collections. I'll go ahead and add that namespace to my project. And so we'll create a new one called my array list equals new array list, like so. And now that I have my array list, I can begin to add items to the array list, like, for example, the car, the first car, and then I can add a second car, like so. All right. Now, one of the problems with the old style collections like the array list is that there was no easy way to actually limit the type of data that would be stored inside of the array. So for example, I want to work with automobiles, but I might accidentally add a book into the array, and it will work just fine. All right, there's no complaints. So the old style collections are not strongly typed, in so much that you can put anything inside of a collection. At first glance that might seem great, but what if I wanted to actually then print out a list of all of the cars, makes, and models? So let me start by, at the very bottom here, type console.readline so we can get through that formality, and then I'm going to just do a for each. And what am I going to work with here? Let's just say I'm going to work for each car in my array list, all right? And then I might go console.writeLine, and let's just go car.make, like so, all right? And print that to screen, and let's run the application, and we will get an exception whenever we hit the third item in our array list. Notice that it has printed the first two to screen, but when we get to the book, it says that there's an invalid cast exception. In other words, we could not convert a car, or rather a book, which was the third item in the array list, into a car. So when we get to this spot in our as we're iterating through each of the items in our array list, we're going to hit a problem here. And the fundamental problem is that we allowed our collection to store something other than cars. So we cannot work with these collections in a strongly typed fashion. Now what I can do, and one of the neat features here, is that I can actually remove that item prior to going into that for each list, and we should just be able to execute the application without problem. All right, so that is at least one of the good benefits there. But unfortunately, the downsides outweigh the benefits, and so let's go ahead and take a look at the newer style collections. The first I said was that we were going to look at a list, and more correctly we're going to look at something called a generic list. So often you'll see it referred to as list of T, like so. All right, and so that of T in the term generic might require a little bit of explanation. When .NET was first released, the first set of collections allow you to put anything you wanted into them, like we saw here just a moment ago. Now, it might make sense in some contexts, but typically it doesn't, and it leads to potential errors like you saw. Now, at some point then, C# introduced the notion of generics. And specifically for our purposes, they released a series of generic collections. And so a collection is essentially generic, but it requires that you make it specific by giving it the data type that should be allowed inside of that collection. So we have a generic list, but we're going to make it a specific list to cars so that we can't even add a book to that collection. So let's attempt to do this one more time. This time we're going to go list, and notice that I'm using angle brackets, and in between the angle brackets I'm going to say what data type I want to use. In this case I want to use the car data type. So list of car called myList equals new list of car, like so. And at this point we can go ahead and add car 1 just fine. We can add car list to my list. We can add car 2 just fine. But what happens when we attempt to add the book into our list? Well, at the point when we attempt to add the book to the list, we get an exception. We hover over and it says it cannot convert a book to a car. All right, and that makes a little bit more sense. It is specific to a car data type, so we cannot add a book to that list. But from this point on, we can work with it now with some confidence. So each car in my list. And we can just do car.model, like so. And we would get what we would expect here. Great. A list of our car models. Okay? So that's one of the big benefits of working with a generic type, is that it allows us to work with a specific data type and only allow those types into our collection. So this is probably the most popular of all of the collections available, but I'm going to show you one additional collection called a dictionary. And a dictionary is similar to, like, think of Webster's dictionary, where you have a word and you look it up in alphabetical order and find the word that you want a definition of. And then once you find the word, you can look to its right and it will have the definition. So there is a key, which is the word itself that we want to look up, and then there is the definition next to it. So there are two components to each entry in a dictionary. There's the key and then the value itself. And so typically when you see a generic dictionary mentioned, it's going to be kind of listed like this: dictionary of T key, T value. So in this case, what we'll do is specify the data type of the key. This allows us to find one specific item by the key. Now the key should be something that is unique to every entry in the dictionary. In the case of people, there might be some identifier. It could be a customer ID in your system. It could be a social security number if you're in the United States. But something that uniquely identifies one entity inside of that dictionary. And then the value can be of any data type. In the case of, again, a customer, you might have the customer ID being the key, but the customer object itself is the value that we actually want to get access to. Now in our case, this seems a little bit weak because our car class only has make and model. And we know that we could have multiple cars that have the exact same make and model. They may have different colors, they might have been created in different years, but you can have multiple cars in the car lot that have the exact same make and model. So neither of these are good candidates for keys, but there is something called a vehicle identification number. So let's go prop string, and let's call this VIN, V-I-N, that will differentiate every car in the world that's been created. So what I'll do is come back up here to the definition, and I'm going to go car 1, VIN, and I'm just going to use a very short VIN number. I think they're typically like 18 or 24 characters long or something like that. I'm not exactly sure, but this should uniquely identify every car in the world, especially every car on our car lot. So now what I can do is create a dictionary of my cars by starting off and saying something like dictionary, and then we're going to give it the two data types. The VIN will be of type string, and then the actual value will be of type car. And we're going to call this my dictionary equals new dictionary of string car. Notice that IntelliSense helped me out by essentially giving me a lot of that, and I can just hit the semicolon at the end of the line for it to type out that entire phrase. And now that I have this, what I can do is go my dictionary dot add, and we'll do car1 dot vin and pass in car as the actual value. So the car1 vin again is our key into the actual car1 itself. Okay, and likewise we'll go add car2 dot vin and car2. All right, and so at this point here, if I were to attempt to find a given item, so console.writeLine, and I need to find a specific car on my car lot, I can allow a user to type in the VIN number and I can look it up in the dictionary quite easily. So say for example I want to do my dictionary dot, and then there's a number of different ways to go about this. I think probably one of the easiest ways, actually, let's go back and not use the dot. And here I'm actually going to use the key itself. So we'll call this B2. And then now we can reference a specific item in the dictionary of type car. So we can get the make, for example, and print that out to screen, like so. All right, we were able to find the geo that way. All right. All right. So hopefully that makes sense. Let's continue on. If you recall, when we originally were looking at and let me comment all this out. We were looking at arrays. I said there's some interesting things you can do to initialize an array with values like we see here. Here we're creating a string of name, an array of strings called names, and to initialize it I give it a collection of names that are comma delimited. And so now I have an array that has 4 elements in it, and it's already been initialized with the values. You can do the same thing with the objects to initialize objects at the point of instantiation. So to do that, we'll use an object initialization syntax. In fact, let's go ahead and just to prove this all works, let's comment out everything we have up here as well. And get rid of the cars in the book. And we'll come down here and go car1 equals new car, and then notice what I do. I use that same syntax, the curly braces. And inside of here, what I can do is actually define all the values. So make equals, let's just dream large here and go make, and the model would be a 750, and we'll make it an LI, and then we'll also give it a vehicle information of C3. All right, like so. So now I've done actually 3 things in one line of code. I create a new variable called car. I create a new instance of car in the computer's memory, and now I'm getting access to that address in memory by using the car1 label, the variable name. And then I go ahead and populate the properties of the car object at the moment that I create that new instance by using this object initializer syntax. All right. Some people don't like this. It looks like it might be doing too much in one line of code, but I think you'll find that if you ever do need to hard code examples like I do frequently, that this shortened syntax actually saves you several lines of code, and it's just fine. It's valid code. All right, so let's go ahead and while we're working here, let's go ahead and create a Toyota. We'll set the model equal to a 4Runner, and we'll give that a VIN of D4. All right, like so. Okay, and so now we can work with the cars just like we did before. But in and of itself, this might not be so interesting. But this is the object initializer syntax, and we can take this one step further when it comes to working with collections. So we can use collection initializer syntax. And I want to point out one other thing, that we didn't have to use a constructor to make this work like we looked at before. That we're able to, regardless of the constructor, go ahead and set these attributes just like we use the syntax there. All All right, but let's now talk about a collection initializer, which can look a little hairy, but it's essentially the same thing. We're just taking it to the next level here. So in this particular case, let's go ahead and create a list of car called my list equals a new list of car. All right. Now at this point, what I can do, and notice that I put this on separate lines here. I typically might keep this on the same line just for my own sanity here. And now inside of this new empty list of cars, I can create a series of car objects like so. In fact, what I can do at this point then is use an object initializer inside of that. So here we'll go, make equals Oldsmobile. And then we'll set the model equal to Cutlass Supreme. And then the VIN number, we'll set that equal to E5, like so, comma, and then we'll create another new car to add to this list of cars. And we'll set its object initializer, setting its make equal to Nissan and its model equal to an Altima, and then finally its VIN will equal F6, something like that. Okay. And now what I've done all in one line of code essentially is I've created a collection and I've added two objects, and in each of those objects I went ahead and already initialized all of their property values. All right. Whew. So there's a lot going on there in just that one line of code. Great. So at any rate, just wanted to recap the things that we talked about in this lesson. First of all, we talked about the difference between arrays and collections, and I promised that there will be a more obvious set of features that are available to collections, which we'll learn about in the next video. We talked about the old style collections versus the new generic collections, and we said generic collections are superior because they allow us to make sure that we're only adding types, specific types to our collection. So we make a generic collection specific by passing in the data type that should be allowed to be referenced inside of that collection. Okay. Then we looked at object initializers, just a shorthand syntax for initializing the properties of a new instance of an object. And then finally taking that one step further within a collection initializer, where not only are we creating a new collection, but then initializing it with new instances of the car collection. In both of those cases, then we are using object initializers. So we can do it all on one line of code. Now, honestly, unless you're building a lot of example code like I do, you may not see this as often unless you are creating some hard-coded objects for use within your application. But I wanted you to be aware of that syntax nonetheless, because we're going to use it again in the next lesson. And we'll see you there. Thank you.